So we're in the year 1905. Maxwell's equations have shown us that the speed of light must always be constant, which violates the classical physics idea of speeds having to be additive. And again, most scientists have sort of decided that this is just a problem with the math rather than an indication of what's really going on, except for Albert Einstein and a few others. So Einstein set out to say, okay, if the speed of light really is constant, what does that tell us about the universe of space and time? Well, speed of light is a velocity. And as you know, velocity is actually a ratio of a distance in space covered over a certain amount of time. Now, for the speed of light, what Einstein said is this always has to stay the same regardless of how we're moving through space and time. Well, for this to always stay the same, regardless of how we're moving through space and time, it's actually space and time that must be able to change. So here's our universe, our grid of space and time. We have certain boxes, and according to classical Newtonian physics, these boxes can never change. But according to Einstein, he came up with the idea that a way to understand the constancy of the speed of light is that space and time must actually be flexible. So if space can actually shrink depending on your motion, and time can actually stretch out depending on your motion, then the mathematics will allow you to keep the speed of light constant. And here is the basic idea that underlies special relativity, or SR, which Einstein published in 1905. Space, he said, unlike what Newton believed, is not an empty nothingness. And time is not just the steady progression of events. According to Newton, space and time are actually linked together as a four-dimensional something that actually has properties, which he called space-time. Space-time is malleable, meaning that it can be changed, it can be stretched, it can be bent, and it is actually changed by motion. That means space and time are relative to how a person is moving. They will change depending on how two people are moving relative to one another. But they will always change in a way that keeps the speed of light constant for everyone. Einstein originally called relativity theory, he called it invariance theory because the whole thing started from the idea that the speed of light is invariant. It only later got changed to the theory of relativity, which is emphasizing the idea that what we measure of space and time is relative to our motion. So the Einstein picture of the universe is very different from the Newtonian picture. This is a photograph that came from that same exhibition that I was at. This is my nephew, who's now grown up and finished his master's degree in history and is now working full-time. But this display here, which had lights flashing through these tubes, was meant to illustrate the Einsteinian picture of the universe. The idea here is that it's actually light, electromagnetic radiation, pure energy that creates a framework for the universe, and that space and time are malleable. They get tucked into the spaces in this framework of light. but they get tucked in a way that the framework never ever changes. So space and time can be squeezed and stretched to fit into this framework of light that is the fundamental um, building structure, building material of the universe.